Alright, chapter 18, problem 32. Find the direction and magnitude electric field that exerts 4.8 times 10 to the minus 17 newtons westward on an electron. So, we know that this force is directed westward, right? We'll call that westward. In part B, find the magnitude, direction, force. Magnitude and direction force does this field exert on a proton? What magnitude and direction, right? So we begin with F equals, right? F equals QE. And so Q in both cases has the same magnitude but opposite sign. So if the E field, if the electric field is pointed, if the force is pointed to the west and we're dealing with an electron, well, the electron has a negative sign. That means that the electric field is pointing to the east, right? Electric field is pointing to the east. So for part A, right, what is the magnitude of the electric field? Well, it's 4.80 times 10 to the minus 17 newtons, right? All of that divided by the charge, 1.67 times 10 to the minus 19th coulombs, right? And so let's go ahead and put in that this newtons west, right? And I'll put in the minus sign here. And so what we're going to get? We're going to get that we have 4.8 E minus 17 divided by minus 1.67 E minus 19. And so minus 287 newtons west, which is 287 newtons east, right? So the electric field, newtons per coulomb, pardon me. So the electric field is 287 newtons per coulomb east. Okay, part B, what magnitude and direction force does this field exert on a proton? Well, this, if we're talking about a proton, now we're talking about the force is the charge of the proton times the electric field, right? So 1.67 times 10 to the minus 19 coulombs times the electric field, 287 newtons per coulomb east, right? And so that's going to give us 4.8 times 10 to the minus 17 newtons in the eastern direction. So we have 4.8 times 10 to the minus 17 newtons westward on the electron and 4.8 times 10 to the minus 17 newtons eastward on the proton. And that's it for problem 32.